Okay. In last lecture we have discussed about different type of Windows function. In this lecture we will do some examples for the Windows function for FIR filter. So the first example is of rectangular window function. So the question provided to us is, using a rectangular window, design a causal low pass filter with a passband gain of unity, cutoff frequency of 1000 Hz and working at a sampling frequency of 5 kHz. Take the length of the impulse response as 7. We will start the solution. Given values are, first is cutoff frequency, that is FC is equal to 1000 Hz, that is equal to 1 kHz. Then Fs is provided, sampling frequency, that is 5 kHz. Now at last it is also provided that the length of the impulse response is 7, that is M is equal to 7. Now this can be used to calculate omega c, which is equal to 2 pi Fc over Fs. So its value is 2 pi, Fc is 1 over 5, that is equal to 0.4 pi. Now we want to design an FIR filter. We want to design a FIR filter. So we'll make FIR filter to have linear phase response. We know that for linear phase response we have 4 kind of filters. First one is called type 1, second one is type 2, third one is type 3, fourth one is type 4. Value of M in type 1 is odd, type 2 is even, type 3 is odd, type 4 is even. Symmetry for type 1 is symmetric, type 2 also symmetric, type 3 anti-symmetric, type 4 also anti-symmetric. Now we have to find out of these 4 which linear phase FIR filter is suitable for this particular example. So we'll look one by one. First of all, M is 7. That's mean it is odd. So type 2 not possible, type 4 not possible. Next comes, we need an LPF filter. Filter is to be designed. So for that particular case, anti-symmetric filters are not suitable for low pass filter. That means type 3 is also not possible. So the only possibility we can have to design a linear phase filter using type 1. So for a type 1 filter, Hn will be equal to H m minus 1 minus and T will be equal to m minus 1 by 2. M minus 1 is 7 minus 1 by 2 equals to First, we'll start from the ideal filter response. Then we'll truncate that particular response to find out the actual filter response we are looking for. So first, ideal filter response. So we know HD omega will be equal to exponential minus j t omega. Okay, it is defined from minus of omega c omega to omega c and 0 elsewhere. In this case, please note that phase delay we have to check if this function is for linear phase response or not. Phase delay is that we know that tau p is equal to minus theta omega over omega, which is equal to minus t omega by omega, that is equal to t, and group delay, that is tau g, is equal to minus of del theta omega over omega equal to minus t equals to t. Both these values are constant, and necessary condition for linear phase symmetric response. So this particular equation which we started for HD omega is equal to exponential minus jt omega from minus omega c to omega c satisfies these two conditions. So now we can find out the value of HD, and that is equal to 1 by 2 pi minus pi to pi HD omega exponential j omega n d omega. Then it can be written as 1 by 2 pi minus omega c to omega c exponential minus j omega t exponential j omega n d omega, and it can be written as 1 by 2 pi minus omega c to omega c exponential j omega n minus t cube. If we integrate this exponential, it will give the value 1 by 2 j pi n minus t exponential j omega n minus t minus omega c to omega c, which will give the value 1 by 2 j pi n minus t exponential j omega c n minus t minus exponential minus j omega c n minus t. Then using 1 by 2j with these exponential terms will give sine omega c n minus t over pi n minus t. Now for the given values, we know the window is defined from 0 to 7, so n will vary from minus infinity to infinity obviously, but we're interested for the values of n equals to 0 to 6, and we know Hn is equal to Hm minus 1 minus n, and this is defined for n equals to 0, 1, 2, 3, 4, 5, 6. So then HD0 will be equal to HD6, HD1 will be equal to HD5, HD2 will be equal to HD4 and then HD3 is alone. Now HD6 we can find out. For HD0 it is sine minus omega c t over minus pi t. Now t is equal to m minus 1 by 2, which is equal to 3, right? Omega c is equal to 0.4 pi, which we have already calculated. Then it can be written as sine 0.4 multiplied by 3, it is 1.2 pi over minus will be cancelled out, so it is 3 pi, and the value is minus 0.0624. Then for HD1 it is sine 0.4 pi 1 minus 3 pi 1 minus 3, which is equal to 0.093. For HD2 it will be sine 0.4 pi 2 minus 3 over pi 2 minus 3 equals to 0.3027. Now for HD3, if we substitute, we will get sine 0.4 pi n minus 3 over pi n minus 3. For n equals to 3, it will be goes to 0 by 0. To remove this situation, we will use L'Hospital rule, that is equal to del by del n sine 0.4 pi n minus 3 over del by del n pi n minus 3 for n equals to 3, and this will give 0.4 pi cos 0.4 pi n minus 3 over pi for n equals to 3. If we substitute the value of n equals to 3 in this particular case, it will give 0.4 pi by pi, which is equal to 0.4. So we have obtained the value of HDN, which is equal to minus 0.0624, 0.0935, 0.3027, 0.4, and then 0.3027, 0.0935 minus 0.0624. Now next in process is the window function. We know that we have to use a rectangular window Wn, which is defined as 1 from 0 to n up to 6 and 0 elsewhere. Then by definition we know multiplying Hdn with Wn, Hdn is an infinite sequence, multiplying this infinite sequence with Wn will give the value of Hn. We have already find out the value of Hdn for that particular window. Another values will go to 0 due to this window function, so we have not calculated those values. So now Hn is also equal to, due to the value of Hdn, Hn is also equal to minus 0.0624, 0.0935, 0.3027, 0.4, 0.3027, 0.0935 and minus 0.0624. These are the values of Hn. Now we want to find out the value of H omega. H omega is equal to summation n equals to minus infinity to infinity Hn exponential minus j omega n. Now this Hn is actually defined from n equals to 0 to m minus 1 Hn exponential minus j omega n So if we substitute the values, that is h0 exponential minus j omega 0 plus h1 exponential minus j omega plus h2 exponential minus j2 omega plus up to h m minus 1 by 2 into exponential minus j omega m minus 1 by 2 plus up to h m minus 1 exponential minus j omega m minus 1. This is the overall series. We have just expanded it up to m minus 1. So if we will take exponential minus j omega m minus 1 by 2 common, if we can take this value as a common, then we will have h of 0. Now it will be exponential with plus sign j omega m minus 1 by 2 plus h1 exponential j omega m minus 1 by 2 minus 1 plus h2 exponential j omega m minus 1 by 2 minus 2 plus it goes up to h m minus 1 by 2. h m minus 1 by 2 exponential minus j omega m minus 1 by 2 is taken common, so it will be only remain h m minus 1. So after the half value it will be h m minus 1 plus 1 into exponential minus j omega, because it will be minus exponential minus j omega, then h m minus 1 by 2 plus 2 exponential minus 2j omega, and then at last h m minus 1 into exponential minus j omega m minus 1 by 2. Right? So we can see by the definition hn is equal to hm minus 1 minus n, that is h0 will be equal to hm minus 1. That's mean this and this are equal. So we can arrange these terms to look like exponential minus j omega m minus 1 by 2, h0 common, then we will have exponential j omega m minus 1 by 2 plus exponential minus j omega m minus 1 by 2 plus h1 is exponential j omega m minus 1 by 2 minus 1 plus exponential minus j omega m minus 1 by 2 minus 1 plus h2 exponential j omega m minus 1 by 2 minus 2 plus exponential minus j omega m minus 1 by 2 minus 2. And at last there will be a lonely term which is hm minus 1 by 2. This equation can be written as exponential minus j omega m minus 1 by 2 h0 So if you multiply this complete equation by 2 and divide by 2, then divide by 2 will be used as cosine omega m minus 1 by 2 plus h1 cosine omega m minus 3 by 2 plus h2 cosine omega m minus 5 by 2 plus up to h m minus 1 by. So now we'll substitute the values. For m is equal to 7, then h omega will be 2 exponential, so 2 exponential minus j omega 3 h0 cos 3 omega plus h1 cos 2 omega plus h2 cos omega plus h3, 2 into h3. So this is the value of the filter response which we have achieved by substituting the value of h0, h1, h2 and h3. We'll get the h omega, which is h omega is equal to 2 exponential minus 3 j omega. Wrong here, this should not be 2, it should be 1 by 2, and here also 1 by. So then plus 0.4 by. So this is impulse response of the filter we have obtained. Thank you.